Hey guys, this is Mr. Lowe. We're covering today the constant of proportionality. So hopefully you remember in class what we did. This is just me going through it again, just in case you missed some of the notes. You can go back and correct it. So the first thing we talked about is how the constant of proportionality can not only be represented by y equals kx, but also by y equals rx. So you might see it both ways. You might see it represented with an R. You might see it with a K. R makes some sense because it might be talking about rate, and constant of proportionality is usually dealing with a rate or a unit rate. So I also went down here and said y equals rx. And our first fill in the blank is the ratio. Y over x is called the constant of proportionality. Which is just the unit rate of a proportional relationship. And it's represented by the variable. This says k way down here, but it's represented by the variable k or r. And I just made my own little blank there. That way you remember that it's represented by k or r, lowercase r. This is all the instructions of everything of how to formulate the equation for a proportional relationship. I'm not going to read that whole thing. I'm just going to go down here and show the example to work through this. Now, in class we were talking about how this is a little bit different than what we've done, but we can use this graph to create a ratio table just like we have before. This is talking about number of cups and then sugar per pound. In a graph, the vertical axis is always your y-axis. The horizontal axis is always your x-axis. So, to make my table, I'm going to say the sugar, that's my x, cups, that's my y. And now I can pull all of these points here and just put them. So my first point is 0, 0. So I have 0 cups of sugar, or 0 pounds of sugar, make 0 cups. Then 4 pounds of sugar is 20 cups. 8 pounds of sugar is 40 cups. 12 pounds of sugar, 60 cups. 16 pounds of sugar is 80 cups. And 20 pounds of sugar makes 100 cups. Now, to double check and to find whether this is a proportional relationship, we still need to check each and every point. Now, it does say that it is a proportional relationship, but we're going to do the same thing that we did in the past, which is divide the y value by the x value to get our unit rate. So 20 divided by 4. I want to know what that is per one. So 20 cups per 4 pounds. I want to know how much it is per 1 pound. 40 cups per 8 pounds. How much per 1 pound? 60 cups per 12 pounds. I want to know how much it is per 1 pound. 80 for 16. I want to know how much it is for 1. And 120. I want to know how much it is for 1 pound. And to do this, we just divide by 4. So that means we get 5 cups per pound. 40 divided by 8. 5 cups per pound. 60 divided by 12. 5 cups. 5 cups. And 100 divided by 20 should be 5. So we now have, again, proven that it is proportional because these all have the exact same unit rate. Now, rather than writing that unit rate, now we're going to create an equation to where we can predict and put it in the form of y equals kx, or y equals rx. Well, the ratio 5/1, we're going to simplify this to a whole number. So 5 divided by 1 is 5. So this is where the difference between unit rate and constant of proportionality comes in. So unit rate we keep as this fraction. So 5 cups per 1 pound. Now our constant of proportionality we're going to use as a whole number. And the other variables in the equation are now going to represent the cups and the pounds. So y equals 5 times the amount of x. When I write this coefficient is the number before the variable. When I write a coefficient and a variable, that means these are multiplied. So this means 5 times x. So this becomes my equation. And we can double check. So I can substitute in this x, 4, put it right here. 5 times 4, that should equal 20. And what this equation is important for is because now we can predict any amount of sugar, any amount of cups. We can solve for any of these variables. But since we know this x stands for pounds of sugar, this y stands for cups, we can solve for any number. So our equation is y equals 5x. So the constant of proportionality is 5. Our unit rate is 5 cups per 1 pound. And see how those are the exact same thing. Now it says below, explain what that equation means in a statement. There's different ways you could say it. I would just explain it as the unit rate, which is 5 cups per 1 pound. You could also say the number of cups is equal to 5 times the amount of pounds. Hopefully that makes a little bit of sense. I'm not going to go through the second example, or the video would be too long, or the second graph, I should say. I'll go through this one just to give us a different sort of example. It says, write an equation that will model the proportional relationship given each real-world situation. Well, I'm just going to do number 2 for now. There are 3 cans that store 9 tennis balls. Consider the number of balls per can. Find the constant of proportionality for the situation. What does it mean for the situation? Write an equation to represent the relationship. So I have 9 balls per 3 cans. I want to find the unit rate per 1 can. So what's that going to be? Well, I have to divide by 3 and divide by 3. So 9 divided by 3 is 3 balls per 1 can. So I found my unit rate. Now, how does this relate to my constant of proportionality? Well, I'm going to use a simplified version of this ratio. So I say 3/1 3 divided by 1 is equal to 3. So the constant of proportionality for this situation is 3. What does it mean for this situation? Well, it means exactly what the unit rate says. I realized I was off the screen there for a second. So my constant of proportionality is 3. It means 3 balls per 1 can. So that's would be A. So 3 tennis balls are in 1 can. And then for B, my equation is simply y equals 3x. So this is what we covered on Tuesday. If you weren't here, you need to copy these down because this is all going to be due on Friday with the rest of the notes and the homework that's attached. So if you need to pause, rewatch, go ahead and do that and make sure you get all of this information copied down.